Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my students. Today we will learn how to do some of the exercise related to the heat transfer specific on radiation emissive power. This small object and this small opening. First, calculate the emissive power of the radiation that emerges from small aperture on the enclosure surface. So the solution, emission from the aperture of any isothermal enclosure will have a characteristic of blackbody radiation, meaning that it will give us the same equation like the emissive power of the blackbody, which is the Stefan-Boltzmann equation, which is the sigma times the T temperature power of 4. So this 5.67 times 10 power of negative 8 is the constant of the Stefan-Boltzmann. And then just insert our temperature, which is the 2000 Kelvin, power of 4. Okay, and then we managed to get the E equal to the 9.07 times 10 power of 5 watt per meter square. Next question, what is the wavelength lambda 1 below 10% of the emission is concentrated? So normally when we have this question, it relates to this diagram, okay, the wavelength and the emissive power. And also when we have this kind of graph, we also can relate this graph as well, this table as well, black body radiation function. Okay, knowing that all this total underneath the graph equal to the 1, which is in the range of 0 until 1. Okay, so next, below 10% refer to the this part, this gray in color. Okay, and this 10% refer to the, let's say the question asks you what is the wavelength lambda 2, for example, above 10%. So above 10% refer to this case, okay, of the emission is concentrated. And then by having that kind of information, we need to determine the function under the graph, which is 0.1 refer to the 10%. Okay, 0.1 refer to the 10% and refer to the table of black body radiation function. Okay, and then we managed to get the 0.1 is somewhere in this part. Okay, in this part, which is the range is from 2000 until 2200. Then we need to do some of the calculation to obtain the exact figure or number or value towards the 0.1, because the 2200 refer to the 0.100888, which is not 0.1 exact. So by having the information, we need to do the interpolation from the table black body radiation function, and then we put from this table, we extract in this table 2000 equal to 0.0666728 x, which is we want to determine, but the function is 0.1, so we put 0.1. and then the next following table is 2200, which is 0.100888. okay, and then we do the calculation according to the table information, and we get the x equal to the 2195. okay, knowing that the wavelength temperature equal to the 2195, and then knowing that from the question the T is 2000, and then we just insert the 2000 on the T and divide to get the lambda 1 approximately 1.1 micrometer. So we already solved the second question. Next, determine the maximum wavelength at which this emission occur. So this question we need to use the wind equation or wind displacement law equation, which is lambda maximum times temperature equal to the 2898, and then afterward we just insert our temperature, which is 2000, and then finally we can get the lambda maximum or wavelength maximum is 1.45 micrometer. It's quite straightforward for this question. Next question, what is the radiation incident a small object placed inside the enclosure? Okay, knowing that the irradiation of small object inside the enclosure approximate to emission black body, so it will give us same answer with the previous slide we have shown earlier, which is G equal to 9.07 times 10 power of 5 watt per meter square. Okay guys, so this is one of the question more or less related, or I would say exactly the same with the previous one. A large isothermal enclosure maintain temperature at 2000 Kelvin, and the question, what is the wavelength lambda 2 above 10% of the emission is concentrated. So do not that worry, because sir also provide the final answer, which is lambda 2 equal to 4.69 micrometer. Okay, so if you found that your answer is not that same as this one, so and you feel that one yours is correct, so you may put in the column, in the comment, so that we can try to figure out what's the actual answer. With that, thank you. Assalamualaikum warahmatullahi taala wabarakatuh. Enjoy your exercise.